Okay, so we'll go back to another video. So here we have a limit, and the limit we're trying to evaluate is actually in a form of a continued fraction. So we have the 2023 times x divided by x plus the 2023 root of x divided by x plus the 2023 root of x divided by x plus so on and so forth. So, you see a continued fraction over here. So we have something to pay attention to. So of course we have the 2023 x, but then there's also the 2023 root of x. So when you think of continued fractions, obviously we know that if we're actually dealing with such, continued fraction, we want to actually make it in a form of a substitution. However, that kind of leads to the question about what happens with the 2023 root of x, because that actually does make it actually does change things up a bit. So the idea behind this is, of course, that we're going to be using a substitution for changing the variables. But actually, we're not actually going to be doing it once, but instead we're actually going to be doing it twice. The whole idea about this is that when we're actually doing that switch of variables to, make the substitution, of course, way you see continued fractions is like in the form of a polynomial, but we have something of a radical as part of our variables. So that actually make things a little bit difficult if we don't actually do things, carefully. So that's the way we're actually going to be doing this. So 2 substitutions, or rather twice the substitution, and then it actually just follows with, some simplifications, and then afterwards you just take the limit from there, and it actually comes down to a very nice answer, which maybe you can probably make a good guess, a hypothesis what the answer is going to be, but, let's see if that's correct to your perspective. So why don't we actually just jump right in? So let's suppose we'll call the substitution, I'll let this be u. So what I'm going to do is I'm going to let u equals the 2023 root of x, but let me actually write that in the exponent form. So x to the power 1 divided by 2023. And what we want to do is to make things a little bit easier, because again, there's x as we have over here, so by itself. So let's actually solve for x. So in other words, x would have to be that it's equal to u to the power 2023. Okay, so with that in mind, and so what we have now is that, so u plus x to the power 1, 2023, then we can actually do the substitution and actually call a new variable. We'll call this y. So y is equal to, so make the substitution that we said that it's also important that we have u over here. So we have u to the power 2023, and then add this with now u divided by, so u to the power 2023, and then add this, so u to the power, or u, and then divided by u to the power 2023, and then continue on, so forth. Okay, so assuming that is convergent, so another way we can write this is the same way as saying that this is u to the power 2023, then plus u divided by y. So going back into the substitution over here, so if we actually put everything back together, so I have 2023 then times u to the 2023, and then all this being divided by y, this continued fraction over here. But we can actually take this a little step ahead further and put in that substitution to say this is equivalent to 2023, then times u to the power 2023, divided by, so u to the power 2023, and then plus u, then divided by y. So with that assumption, so now we can actually make things a little bit easier and solve this out. So of course our numerators are equivalent to each other, so now we just set the denominators equal to each other. And to the point that as we solve this out, we get something in the form of a polynomial that we're actually solving for our solutions. So now we look at this, and if I actually, so let me put this as, now look at y, and then equals u to the power 2023 plus u, and then divided by y. If I solve all this out, so that means I multiply the y to both sides. So y squared then equals to y times u to the power 2023, and then plus u. Okay, so now I can actually just solve this out in the form of, like simply in the form of a quadratic equation. So let's solve this and subtract everything on the opposite side. So now that'll yield us with just y squared, then minus y times u to the power 2023, and then subtract u, and then set this equal to 0, okay? So we're actually going to be solving for the variable y. And of course, when we're actually doing so, we're going to be using the quadratic formula. And we know with the quadratic formula, there's actually a plus and minus. But keep in mind that we're actually solving for the positive. So specifically, y is strictly greater than 0. So we actually just apply this if I solve for y on its own. So that means y is set that equal to, so, negative b. So in this case, that will be minus u to the power 2023. So that'll change that to a positive. So u to the power 2023, then plus the square root, Now that means I have u to the power 2023, then square, then subtract 4, then times, in this case, this will be 1, and then over here minus u. So let's change that up and say that that becomes now positive, so plus 4 times u, and then divided by 2 times a. Our a in this situation is going to be just 1, so 2. Simplify this out a little further, so I have u to the power 2023, then plus the square root of, simplify this out, so I have u to the power 46 plus 4 times u, and then divided by 2. So now with that in mind, we can actually go back to our original limit that we have, and keep in mind that we actually just changed the variable. Now we're actually doing this in terms of u, so change that. So as x approaches infinity, then of course that doesn't really change much, so that means that the limit as instead u approaches infinity, that's what I meant by saying nothing really changed, not to get that confusion. So now just put everything back, so 2023, and then substitute the x for what we have for u, so u to the power 2023, all this being divided by, so now just substitute the y that we have from over here with what we solved for this right-hand side. So u 2023 plus the square root of u to the power 46, then plus 4 times u, all this being divided by 2. Of course, we can actually simplify some things, so multiply 2 to both the numerator and denominator. I get a 46 over here, so I'll actually just factor that out outside. So 46, then the limit as u approaches infinity of u to the power 2023, and then divided by, so u 2023 plus the square root of u 46 plus 4 times u. So there's some ways to actually simplify this out. If you want to take the longer approach, and I guess this is, a lot of people can learn this from calculus when you're dealing with limits, is you can actually multiply its conjugate from both the numerator and denominator. So it would be u to the power 2023, subtract the square root of u 46 plus 4u to both the numerator and denominator, and then simplify that up if you want. I'm just going to tell you straight off the bat that I actually did this method myself, and it's actually kind of difficult to do so. So I'm going to give you the simple method. What you can do is let's actually divide the u to the power 2023 to both the numerator and denominator. And what that will do is that, so 46, so let me first write this out. So if I were to perform the division, so of course u divided by u to the power 2023 divided by u to the power 23 is just going to be 1. Okay, so if I divide this to the denominator over here, divide by u to the power 2023, so that'll just leave us with 1, and then add this with 1 divided by u 2023, then multiply with the square root of u 46, then plus 4 times u. And what I can do is simplify it such that the 1 divided by u to the power 2023, we're going to put that back inside of the radical. And that means that squares that out. So that means inside the radical, we have everything divided by u to the power 2020, or u to the power 4046. So then now we have that, so this is 4046, then times the limit as u approaches infinity of 1 divided by 1 plus the square root of 1, and then add this with 4 divided by, so divide by this, I have now u to the power 4035, okay? And now, simple as that is we take the limit as u approaches infinity. This is just going to approach 0, so I have 1 plus the square root of 1, which is 1, so which is just 1/2, and so therefore I have 4046 times 1/2, therefore simplifies to simply just 2023. And so therefore that is our final answer to this continued fraction of a limit. I might as well call this title a 2023 limit if you think that's actually helpful. So there we have it. Nice limit of a continued fraction. It actually comes down to something simple. So as mentioned, you probably could have guessed that in the beginning. So yeah, that's pretty cool if you ask me.